Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to use the Laplace transform to solve y prime minus ay equals e to the ct. And so let me write a few things down. We said that the Laplace transform of e to the at is equal to 1 over s minus a. And we also said that the Laplace, we said another thing. We said that the Laplace transform of some function y of t is equal to capital Y of s. And we also did one more thing. So we did that. And the last one we said the Laplace transform of y prime of t is equal to s times capital Y of s minus y of 0, our initial condition. Now I'd like to bring in another concept, and that is the idea of the inverse Laplace transform. So the inverse undoes what you have done. So if I took the inverse Laplace of the Laplace transform of e to the at, well, that would just undo this. In other words, I would get e to the at. Well, notice this. If I take the Laplace, so if I in the same idea, if I apply the inverse Laplace transform to 1 over s minus a, well, 1 over s minus a, that's the Laplace transform of e to the at. So the Laplace transform of 1 over s minus a just takes you back to what was originally transformed. Okay, another idea would be that if I took the inverse Laplace transform of y of t, wow, there's a lot of parentheses there. That would give me y of t. Well, let's try that again. If I take the Laplace transform of capital Y of s, well, we said capital Y of s, that is the Laplace transform of y. So the inverse of that would just bring me back to the original function that was transformed. We need that idea to solve this. So now let's solve our problem. So the Laplace transform, I'm going to solve, so we're going to now solve y prime minus ay equals e to the ct. Well, we start by applying the Laplace transform. So we're going to apply the Laplace transform to both sides. Y prime minus ay equals the Laplace transform of e to the ct. Well, let's try this. So remember we said Laplace is a linear operator. So this is the Laplace of y prime minus, and a is just a scalar, so factor out my scalar, times the Laplace of y. And the right side, we'll just leave it. We'll do all of our transforms at once. Laplace of e to the ct. So on the left, I have the Laplace of y prime, that's s capital Y of s minus y of 0, minus a, and the Laplace of y, that's just capital Y of s. And this is going to equal the Laplace transform of e to the ct. Well, we did one for e to the at. Now we're just replacing the a with a c. So this is 1 over s minus c. Okay, now here's what we do. We solve this problem for capital Y of s. And then in the end, what will we have? Then if we take the inverse of the capital Y, we're back to y. So let's see if that's how it works. So solve for y of s. I'm going to do two things. I'm going to factor the y of s, so capital Y of s. And that leaves me with an s minus a. And then let's move that initial condition to the right-hand side. So I'll write this as equals y of 0 plus 1 over s minus c. Okay, divide both sides by s minus a. And so we have that the y of s is equal to y of 0 times 1 over s minus a plus, I'm going to write this out as 1, we'll just write it out, s minus a, s minus c. Okay, now remember, we don't know anything about 1 over 2 factors. We just know something about 1 over s minus a or 1 over s minus c. So what we're going to do now is we're going to use partial fractions. Use partial fractions. Use partial fractions to, we'll call split apart. Split, SP, to split the second term. Second term on the right-hand side. All right, so here we go. So 1 over, I'm hoping to fit this on one page, but I have a feeling it's not going to. 1 over s minus a, s minus c. This is equal to some a over s minus a plus b over s minus c. All right, the next thing we're going to do is multiply through by the common denominator. So when we do this, we're going to get a 1 on the left-hand side. Oops. And you get a 1 on the left-hand side. And then the s minus a's will cancel, so we'll have an a times s minus c plus b times s minus c will now cancel. So we're going to pick up s minus a. Okay, and then to solve this, there's a few different ways. You could distribute and match coefficients, or another way is to say let s equal, let s equal a. Then what do we get? Well, when we let s equal a, then the whole b term becomes 0. So then we're left with then 1 equals a times, and then we substitute the s in for the a, so we have an a minus c. So what do we say is we can say that a, capital A, is equal to 1 divided by a minus c. And we can do that again similarly, and let, or you could also say when s equals c, well then what do we have? When s equals c, then the a term, the first term, becomes 0, and so we have 1 equals capital B times, well, s is now c, so we have c minus a, or we can say that b, capital B, is equal to 1 divided by c minus a. Okay, now I can use my partial fraction to rewrite the original equation. So let me just grab a highlighter here, and if we look at this, this is our original equation, and now it's this second term that we can expand using the partial fractions decomposition. So let's write this. So now I can write capital Y of s is equal to y of 0 times 1 over s minus a plus, and then the first one becomes the a over s minus a. Well, capital A is 1 over a minus c, so 1 over a minus c times 1 over s minus a plus, and then the b over s minus c, well, b we found out to be c minus a, so 1 over c minus a times 1 over, and then the b is s minus c. Well, now what we want to do is now we're going to undo all this. And when we do this, we do that by applying the Laplace transform. So when we apply it, we're going to take advantage of the linearity fact. And so what we're going to do is when we apply the Laplace transform, remember, it's a linear operator, so the coefficients can get factored out. Oops. And we're going to be looking at it, we're applying it to each of these terms, or to the factor of each term that that is a function of s. And so the 1 over a minus c, the y of 0, and the 1 over c minus a, those are just constants. So here we go. So let's apply this now. Let's apply this. We're going to apply, and I'll write it out, the inverse Laplace of capital Y of s equals, and then we write y of 0, because we're just factoring it out, the coefficient, times the inverse Laplace of 1 over s minus a plus our constant 1 over a minus c times the inverse Laplace of 1 over s minus a plus 1 over c minus a times the inverse Laplace of 1 over, sorry, there's a lot of extra dots there, 1 over s minus c. Now we can use what we've worked so hard to learn, and that's what we've got here. So look at what we've got. We've got here, we know that the inverse Laplace of y of s, we did that earlier today, we did that right here. The inverse Laplace of y of t, that's just of y of s is y of t. So let's write that. So then I can say that this is y of t equals y of 0. And then the inverse Laplace of 1 over s minus a, well, we took care of that one too. Remember, we said the inverse Laplace of 1 over s minus a, that's just e to the at. Remember, that's where that function of s came from. So that's e to the at. And then plus, we have another constant, 1 over a minus c. The inverse Laplace of s minus 1 over s minus a, we know that. That is also e to the at plus 1 over c minus a. And then the inverse Laplace of 1 over s minus c, well, now the c has just replaced the a, so that just becomes e to the ct. And it's often written as, okay, and we're almost done. Our last step, I'm going to just notice that if we make this a constant, if we just multiply that term by -1 over -1, we'll have a combinant denominator. So you could do that if you want. I'm going to rewrite it this way. You could also say this is y of t equals, I'm going to factor out the e to the at, so I have a y of 0 plus 1 over a minus c times e to the at plus 1 over c minus a e to the ct. And the reason for doing that is, notice what this is. This is, now I've just written it, this is my null component plus my particular component. And that's how we can use the Laplace transform to solve a first order linear differential equation. I hope that helps, and thanks for watching.